define variance. It is the square of the standard deviation. Okay, so we have sigma squared, that's for population variance. And then we have S squared, that's for sample. We use number 1 again. Here you just find standard deviation and square it. Obviously you need to pick the right one because these are going to differ on your calculator because of the formulas we talked up above about. But your calculator doesn't give you the variance, so you just have to find the standard deviation and then square it. In previous examples, we considered population data of exam scores in a statistics class. For this data, we computed a population mean of 79 points and a population standard deviation of sigma equaling 9.8 points. Then we obtained a simple random sample of exam scores. For this data, we computed a sample mean of, okay, let's figure that out. That was 3.1. Sample mean was 77.67. And a sample standard deviation of right here, 10 points. Use the population standard deviation exam score and the sample standard deviation exam score to determine the population and sample variance. So sigma squared, we're just going to take 9.8 and square it to get our variance. So this is 96.04 points squared. Then for sample variance, we take our S, so 10, square that, and that's 100 points squared. So we have learned for dispersion, range, standard deviation, and variance. Range does not give us very much information, and variance is in a weird unit that we're maybe not used to. So we're not used to seeing points squared. So for most of this course, we will be using standard deviation.